So, class, yesterday we talked about the hydrosphere and even mentioned that the water contained in the atmosphere in vapor form is indeed part of the hydrosphere, right? Well, we've thrown this term atmosphere around a lot lately. Just what exactly really is the atmosphere? Well, to start, the atmosphere basically covers the Earth. It is the thin layer of a mixture of gases that make up the air that we breathe. It also helps the Earth from becoming way too hot or way too cold. Now, in terms of just exactly what the atmosphere consists of, it is important to remember that over long periods of time, this can change. Currently, however, we are very aware of exactly what proportion of the atmosphere consists of what. To start, the majority of the atmosphere is actually comprised of nitrogen, as you can see in our pie chart to the left. 78% of the whole atmosphere is just nitrogen. Nitrogen alone. Now, when you think of air, you probably think of oxygen, so this may be a bit surprising. Aside from living beings actually needing nitrogen for certain processes to work in their structures, it actually regulates the temperature of the Earth as well. If there was no nitrogen in the atmosphere, the Earth would be way too hot on which to even live. Now, if you first thought of oxygen when I mentioned the atmosphere, you'll be happy now, because the second largest component of the atmosphere is indeed oxygen. It makes up 21% of the atmosphere, and what we should all know, why this is necessary to life on Earth at this point. Aside from being necessary to processes like cellular respiration, oxygen actually regulates the Earth temperature too, balancing out the presence of nitrogen and keeping the Earth from becoming way too cold. Now, if you do the math, you'll realize that nitrogen and oxygen make up almost the entire atmosphere, as 78% plus 21% equals 99%. There are a few other components, such as carbon dioxide, that water vapor about which we've been speaking, and a few others, but their presence is minuscule compared to that of nitrogen and oxygen, which is really, really important to remember. All these trace gases combined make up just about 1% of our atmosphere. Now, take a moment to watch this Bill Nye the Science Guy clip on the atmosphere. If you cannot see it or cannot hear it for some reason, there is a link to the YouTube video in your freshman science playlist.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
If mountaintops are closer to the sun, why is it always colder up there than it is down here in the city? Well, please consider the following. Our atmosphere is thin, but it's thick enough to keep us warm. Now, when you're wearing a coat like this one, it keeps you warm because it holds air next to your body. The same thing with the atmosphere. There's more air above us when we're down here in the city than when we're way up here in the mountains. So it's like the world's low places are wearing more coats. They're wearing more air than these places up high in the mountains. Now, as you travel up through the atmosphere, it gets colder and colder because the air gets thinner and thinner until you're up around 10 kilometers. That's when you leave the troposphere and enter the stratosphere. Anyway, the rate at which it gets colder is called the lapse rate, and it's about 5.5 degrees Celsius per kilometer. So a mountain, say 3,000 meters high, let's see, that's about 10,000 feet, would be about 17 degrees Celsius colder than it would be down here in the city. And that's plenty cold enough for there to be a spring shower in the city while it's snowing up in the mountains. Thank you for joining me on Consider the Following.
Bill Nye the Science Guy.